Welcome to this third Munch Learn. I'm Didier Lally. I'm part of the HPE developer community team. Together from that team, we also have Fred and Denis that be helping me handling the crowd here. And for this third session of our Munch Learn series, which is a monthly series, we have Doug and we have Ellen that will be delivering that unplugged data science session without any single slide. However, I have a couple of slides just to give you a few housekeeping items. We are trying to make this fun, and I know Doug will also make this fun. But in addition to Doug making that fun, we have a number of things we like to say. First of all, we have a calendar of those events on that web page, and I will put all the links in the chat. We'll use the chat for questions and also for dropping some important links. The calendar is over there. You can register for the upcoming events, and you can find also, very important, the replay links of the past events. The next session that we will be doing over the next 2 months is in April. We're going to have a session on SPIFE, which is called the Building of a Foundation for Zero Trust with SPIFE. And we'll have one speaker from HPE, Daniel, and one speaker from Doc.ai, Frederick. And in May, the session will be the part 2 of this exact session that Doug is doing. So Doug will be doing a 2-part session. The part 1 is today. Part 2 is in 2 sessions from now in May. And the fun part that I was talking about is the fact that we have created a Slack channel in our Slack workspace dedicated to Munch Learn. So we'll drop those links in the chat again. But if you first register to our Slack, then you join that or you open that Munch Learn channel, you can upload picture of your favorite munchies, and we'd be happy to see that. Fred has already started. You can also tweet and put a picture of your munchie and use the hashtag for HPE Dev if you do so. With that, let's get on with the real stuff, and the floor is all yours, Helen.
Well, good morning. Always glad to be doing things with the HPE Dev community. Today is different. I think our theme is everything's different. The first thing that's different is that in North America, we've had our time zone change away from daylight savings time. I think in Europe, in the UK, that hasn't happened yet. So this is the unusual Munch and Learn, and that it's a little later for us. And so I use this as my excuse that instead of a nice healthy breakfast at 8 a.m., I'm having a tea biscuit and pretend I'm in Chicago instead of the West Coast of the US, and time for a tea break. And still joining those of you who are lucky enough to be in European time zone. I think it's 5 p.m. there. To all of you in India, you're having a late night snack while you listen to this. If you're listening to us from Japan, I don't know why, you should be asleep right now. So you're having an after midnight snack. So our theme is that things are different, and it's certainly going to be different because Doug is going to do a different type of presentation here without slides, very active and interactive presentation as a whiteboard, as though we're all right here in the room with him to do that. And really the theme, I think, for how we're looking at data science is different. It's what can make a difference. Data science can be wildly successful and have tremendous payback. I'm thinking of a few years ago when I was working with MapR Technologies, and a large financial institution came to us. They wanted to start a recommendation system, do some upsell on one of their lines of business. And this was with an excellent engineering team, but they absolutely had never done any machine learning before. But they had good advice. They understood their data. They understood how to use the meaning of what their data would tell them. They had a great data delivery system in MapR, which later became HPE Data Fabric. They had some super bright engineers and developers. And they basically took this from an idea to an in-production system that was bringing in millions of dollars of extra revenue in under 5 months. And that was years ago, and techniques are even better. So it really does make a difference how you approach this, how you work with your data. And one of the things that Doug has talked about, Doug is a field CTO for HPE. He is also a prolific writer, and one of his many articles that he wrote within the last year is one on industrializing data science. And one of the points that he made in that is that you really have to think of data science as a series of individual steps, of individual handoffs. It's not just about the model and just about the algorithm. You have to get those other parts right. And he talks about, in that article, an industrialized approach. How do you deal with those pieces? How do you deal with the things that are being repeated and unnecessarily repeated, and basically industrialize and make them more efficient? So I don't know exactly which aspects of data science Doug's going to dig into for us today, but I know it's going to be good, it's going to be lively, and most importantly, it's going to be practical. It's going to take us into the real things that can make a difference in working with data. He has 25 years of information management and data science experience across Europe, the Mideast, and Africa. He's worked with a number of different companies, so he has a lot of insight into this. So I'm about to hand off to Doug, but before I do, let's start with all of you, the audience, and get a better sense of who's joined our group today. So if you would please respond to this first poll question and give us a little sense of what is your experience level with data science. It's something that's very new to you, your first choice there. You know some basics, but maybe you've never really done this yourself, or you're a little unclear of how to fit it together. You're doing it and trying to understand how to do it better. I'll rephrase the last one as you're a practicing data science superhero and know everything there is to know about it, and we'll be hearing back from you as well. Anyway, have some fun with this, but let's have a response to our poll. Didier, how long do we leave the poll open?
Oh, you're on mute, Didier.
Yeah, sorry. Let me know, and we can leave it up to.
How many people have we got in total?
Well, 117 right now.
Wow.
So 95 people responded. So
can I just say, the 3 practicing data scientists should leave the room now, because this is going to be a train smash, whatever happens.
Okay, right? I'm going to disagree with Doug, and I know that people, the more experience they have with data science, the better they can appreciate actual practical advice that makes this stuff work in the real world. And if not to learn something for themselves, but to learn how to better communicate this to other people. So Doug, we need to keep those three people in the room.
Okay.
All right, so please, as we close the poll, do throughout the talk, if you have questions, put them in the chat. Didier and team will be watching the chat. I'll watch it a little, but mainly I'm going to be listening to Doug.
I think
I'm going to be listening to Doug. I've got my notebook and my own little whiteboard here, so I can follow along. And here's back to Doug. But do we have the poll results, Didier, or will we get those later?
We do have. Do you want to share that?
Do you want
to
share
think
it?
a quick share on that one would be nice.
There you go.
So fantastic, really. As I say, the 3 practicing data scientists, though, need to leave the room, or we're going to be in trouble. No, seriously. It's such a broad kind of thing, really. And to be honest with you, I'm really not that sure about what I'm going to talk to you about. But hopefully it'll be interesting. It's just a different approach. I mean, I don't know about you, but I'm not only suffering from Zoom fatigue, but also PowerPoint fatigue, I guess, horribly, right? So I just wanted to share what is probably going to be more of a stream of consciousness than anything else. So I'm going to, forgive me, but I'm going to stop the video. Otherwise, we're not going to get bandwidth on this device. So all I'm doing is going to share, hopefully, my desktop. My screen. I've got an iPad here, and we should be hopefully in broadcast mode. So okay, so
Yep, we can see your screen.
You can see it. Okay, brilliant.
Yep.
All right, so look, this is a slightly different thing. I was just going to try and answer some questions, really, just to do a trot through. And whether we have session 2 or not is completely up to you. If it's something that's interesting, let's do another one. If it's not interesting, let's by all means not do another one, right? Because there's no point. And if the format doesn't work for you as well, if you don't want to do whiteboard, if you'd rather have some slides or a discussion, that's great. Of course, in this format, it's very difficult to have you all on voice and have you all interrupt and wave a hand and ask a question. But maybe we'll stop every once in a while. Hopefully, Ellen will keep me honest. And you probably would have seen in the bottom here, there's a reaction icon as well. And so you can say, go slower, go faster, thumbs up, this is complete rubbish, let's go on, and all that kind of thing. What I can promise you is I don't actually have any slides, although I have cheated somewhat. I've put just one image in there, actually, which I thought you might find interesting. But there's going to be no selling, there's no product here. This is really just a general chat about the stuff that I've done around, expert systems, data science, KDD, data mining, over the years with various vendors and things. So I just wanted to share some of that, if that's okay. Okay, so let's get started. I thought you might be interested in this. We happened to run recently a round table for some of our best kind of customers in financial services recently. And it was such an interesting thing, actually. So these are all lead data scientists from the likes of HSBC and RBA. So lots of large banks, if you will, right? And I just thought it was so interesting, mainly because they were really echoing many of the things that you've seen recently around the biggest challenge, as you can see here, is things like delivering data science at scale. So it's really not about doing data science one-off. It's how do I take that data science and how do I, this last mile problem is the thing that features here quite a lot too. How do I then operationalize those models, get them into production, monitor and manage those at the same time as then doing the next set of models too? Also really important, I thought, is this whole thing about data. The whole thing about data hasn't left the room. And I just think that's, I don't know why we haven't, oh, sorry, I should have turned all that off. I don't know why we've not figured out the data thing yet. I come from a data background, and anyway, so these are the problems we're going to discuss, right? So let's move on. So let's start off with, what problem is data science trying to solve? Now, look, there are any number of ways of doing this, right? So I'm a graph guy, so as opposed to a giraffe guy. So if we were to just plot a simple graph, so, we've got data volume, and forgive my handwriting really, especially when I'm nervous and we've just started out, against time. So I'm going to suggest that, well, take an example, right? Let's imagine for an example that you're all shopkeepers and you've started a shop, right? So we've started a shop and we're down here. So we've got this retail shop, and you welcome the first customer across the threshold, you follow them around, you try and help them, and you've serviced them very well, you've served them very well, you get more customers, and the data volumes, of course, go up, right? So we are sort of driving up data volumes here. And then we get to a point maybe where all of a sudden we've made loads of money with this store, and we open another store, and we open another store, and another store, and another store, and another store, right? And so the data volumes are going up like this. Now, at the same time, if you think about the level of understanding you have about your customers, then it's reasonable to suggest that we would have tracked fairly close here for a while, but past a certain point, there's no way as an individual you can keep up with things. Now, when you first opened the shop, you knew all of your customers by name, right? Fairly straightforward. Shirley and Brian and Stephanie and Jan and all of the others. So we can reasonably suggest that this kind of is really is an intimacy gap. And this gap represents that lack of understanding, if you will, the kind of the understanding between what you used to know. So, you know, if you were doing, say, you know, I don't know, range planning, for instance, or, you know, assortment planning. So, so you got the right, you were selling clothes as well as everything else, and you get the right sizes in the store because you understand and know the people that come into your store. You know how much disposable income they have, maybe. So you're doing pricing. You know how to do promotion. Yeah. You know how, when you delist a product, so you've got a limited amount of space in your store. When you delist a product, you know how important that product is to your customers because your customers come and tell you. So reasonably. Is that question or just background? Just get background. Plugging on. Okay. So you get the idea, okay? And in fact, Forrester have suggested that there's something like 40 zettabytes of data available for analysis. And really what they've also said, this is Forrester, really, that 98% of IT leaders believe that machine learning is the answer to this gap. Okay, so it's validated somewhere else, but there's another gap as well, which is even more important, I think, which is kind of, it's fine to know and understand these things, but actually there's also a gap about what you can do about it, which is also really interesting. And this is really an execution gap. So it's fine to know so if you know who your customers are, fine, but how do we attract new customers? How do we drive campaigns that will attract the right kind of customers to us, whatever we're doing? And that's really about this execution gap. And Forrester have also said that only 6% of their, in fact, I think it was 6% of their data science leaders, but I can't really be certain because I can't really remember the research right now, have a mature enough MLOps capability. So in other words, although they're able to do some of the data science, what they can't do is they can't pipeline that data science from the development stage, if you like, get it out of the lab and into a production context, which we're going to look at in a second, and actually execute. And that's backed up by people like Gartner as well, who've always got something to say about these things. And they're saying that 80 to 85% of customers have what they're calling this last mile problem. And the last mile problem, really, as it implies, is, okay, we've got the data science now, but how do we operationalize it? And what do we operationalize it into? So fundamentally here, really, we're talking about, well, in fact, what we're really saying is, in order to do something about this, if you were to think about it as a, this is demand, if you like, right? So we've got, what we've tried to picture is this, demand growth for data science. That data science is executing across this exponential growth in data. Okay, hopefully you agree. At the same time, while every university out there is producing new data scientists, they're minting new data scientists, they're coming out the door. The increase in the number of people that are, on LinkedIn who are suggesting they are data scientists is certainly going up significantly. But of course, demand is also outstripping supply. So even though you may see an increase in the number of data scientists in your organization, actually there's nowhere, you're not going to get the kind of exponential growth that you might need to keep pace with demand, are you? And in fact, moreover, it's very likely that you're going to see flat or declining number of data scientists. And lastly, I'm going to suggest that budgets are also pretty flat or declining. So especially, post-pandemic, right? So what that really means is that we can't just throw GPUs at the problem. We can't just throw technology here. This is really about, productivity. Hopefully you agree. So in other words, and this is the productivity of not just the data scientists, actually, and we're going to look at this, but it's really productivity of the team. So we want the data scientist to do the things that the data scientist has to do, but we don't want the data scientist to have to look after infrastructure. we don't want the data scientist to have to rebuild, petabate a model that's decayed and could be easily rebuilt, if you like, to give you the same performance again. We don't want the data scientist to have to monitor the models. We don't want the data scientist to have to scale the models. These are things that infrastructure and IT should be able to manage. They are things that the site reliability engineer should manage. They're things that the ML engineer should manage, or the data engineer should manage, right? So it's about the team, not about the data scientists. It's also about efficiency and effectiveness, but I guess that's something else. And maybe also it's about citizen data scientists. So asking other people, if you like, to step into the fray and being able to develop perhaps not the most important model to you, but supporting them in actually developing other models, if you like, right? But it is really about being a team sport. Does that make sense? Somewhat, a little bit. I'm just going to quickly, I'm afraid to do so, but I'm going to check on the questions. Anomaly detection, problems and solutions. Happy to talk to you. Please contact. Anomaly detection is a particular thorny problem which we can look at later. So anyway, right, I'm going to flick on. Is that okay?
Doug,
Hopefully that's okay. Yep.
Doug, I'll just jump in. I think it makes a lot of sense. And one of the things that you said that I think is hugely powerful and can be easily overlooked is you touched on that issue of the separation of concerns, how to get each group doing what they do and doing it efficiently and not redoing things that don't need to be duplicated. So just, that's very, very good advice.
So what kind of problems should we be tackling was that the next thing I was going to discuss, right? So again, you can tell I'm a graph person. So if you looked at the value of an individual decision, if you like, versus the complexity or frequency, I should say, rather. Versus the frequency of the decision. In fact, the axis is probably completely wrong. So it's reasonable to suggest that there are some decisions, for instance, like this decision here is, Antonio buying a new company, right? Acquisition. So this is a decision that doesn't happen very often. It's probably really all the way over here. Doesn't happen very often, happening more frequently nowadays, of course. But it's supported by a bunch of analytics that's going to be run, sure. But at the end of the day, it's a qualitative decision. It's very unlikely that would be a computer-mediated decision directly. The same is true of certain work like, brand management, for instance, where you might be doing, you might have impression management, you'll have a whole bunch of data coming into some kind of cockpit. But at the end of the day, you're making decisions based on your analysis, your interpretation of a number of things. More focus is kind of over here. So if you like, this might be a fraud type problem, for instance, where much higher frequency, still of great value to the organization. And this is where a lot of work is being done. So fraud would be one of them. Further down here, I'm going to argue is, things like maybe churn analysis. But what you tend to find is that because of the problems that people have had with the last mile problem, there'll be a group of problems around this space, if you like, right? So these will be a number of things that people are tackling. But because of the last mile problem, and the last mile problem really says that it takes a long time, a lot of effort, there's a lot of risk because a lot of projects fail, basically, right? As a result, what tends to happen at the moment is a lot of customers that we see focus more of their efforts on these, what you might say is, very clear ROI pictures here. So if we manage to solve this problem, there's a massive ROI and we're all good. And that's why all of those banking customers that we started off by talking about, they'd all kind of, in their own way, solved some of the last mile problem. But what they've done is they've solved it by paving the road from where they were to this last mile. So they paved that last mile of road, What they hadn't done is generalize. So what they weren't able to do is then tackle different types of problem. What they've done is specifically solve the problem, if you will, right? For you. What I really want to do,
Doug,
yeah,
we've lost you for the last 20 seconds. Sorry about that.
Okay. Lost the image or lost me?
No, lost the talking.
Okay. So going back, so what I'm really trying to say is that there's a great unwashed here, and there's a great opportunity for us to basically grow this. So if we do this right, if we were able to seamlessly and effortlessly create models and then productionize models, we would be able to tackle many more models, right? We would also be able to tackle many models with a much less well-defined ROI. So we'd be able to grow this estate out from here. And you know, that's after all what we're trying to achieve. If you just stick to a few of these problems here where you know, where there is high ROI and well understood ROI pictures, it's really missing the kind of the thing that we're trying to do right now, which is really making every application as smart as we possibly can. So, you know, if you have a dial with your applications on here, right, and if you have a choice between dumb over this side, so this is my dumb application, and smart over here, you know, we are definitely trying to push this dial up this way, right? So we really, really need to think about this, this whole idea of having an application which is kind of, well, this is my application. So this is my, I'm application centric as an organization, because nothing happens in my organization if it's not built into an application. But I really need to be insight driven, don't I? Right? So unless I'm intertwining my kind of the knowledge, the insight that I'm getting from my data, unless I can take that knowledge out of my machine learning models and operationalize it into an application, it's really not creating value for me. And that's really what we want to get at, right? So the focus here is trying to make sure that we have enough headroom in our data science to be able to operationalize trivial models, silly models, things that have got marginal value, but maybe a gateway to kind of bigger savings in our organization. There should be no problem that isn't optimized in some way within an application. And that might mean many, many, many different types of decisions, if you like, that we're going to tackle. Yeah, does that make sense? A little bit? Kind of? Oh, God. Well, let's look at an example. Let's miss that for a second. Let's look at an example, right? So let's look at a retail example. So we are all shopping at home at the moment. So let's look at a simple retail example. Let's choose a pen. Right, okay. So I've got this portal here, right? I've got this e-commerce site. And I've got an e-commerce site, and this is Doug's Emporium, right? Or welcome. So I'm going to have to Doug's site. Okay, and I'm going to have a banner here. So spend €50 and get 20% discount. Seems extraordinary, great value, you know, so. Okay, so let's just do 3 panels here. So 3 random panels looking at this, and forgive my use of the whiteboard. But let's say I'm selling here. I'm selling some trousers, or khakis, as you might say in America. I've got a vase here, vase, and I'm selling this fancy ladies' watch here, right? So. How would we use data science here? Well, I mean, surely it's kind of like, well, everywhere, isn't it? So what should the salutation be? Discount rate. and the threshold as well, right? What about the color? What color should I use? What images should I use? Should they be young? Should they be old? Should they be fancy? Should they not, right? If I'm going to search, then what order should the search results come back in? Should the search results come back in natural order of interest? Maybe what I can do is multiply the probability of you responding to the order, to the offer, or the search item, by the margin we make. So I can rank them in kind of a likely order, or likely, sort of net value to me, if you will, that kind of thing. So there are any number of places I could really kind of optimize this site. I hope you agree. Okay. And so, well, how is that all going to work? Let me just shrink this down a little bit if I can. Yeah, resize. So if that's my website, then how's it going to work? Well, so inevitably I'm going to have some code that's going to run, let's say, right here. So it's going to be some, so we're going to have some code run here in our web server, right? And this is maybe a load event or something, page load event, right? And that page load event, at some stage, let's say it's looking at, say, the discount rate, it's going to call out to my model serving. So I'm going to have here my model serving. And in here, I'm going to have a wrapper code. But in the model serving, I'm then going to have a series of models, right? Very bad to sort of show the model. And so I'm going to call out to that model. Maybe when I come into the page, I've hit a cookie, the cookie's responded, I've been seen before, they know who I am, maybe I'm a loyal customer, and I'm going to bring back the discount rate, if you like, for that particular customer. Probably what's happened in the background as well, I would have probably pulled a bunch of data from a NoSQL database with things like permissions and preferences and that kind of thing at the same time, right? The web server's writing logs away. The logs are probably streaming into some kind of Kafka engine. And that might also be consumed by another set of processes, which, let's call them next best activity or next best offer, or alerting system of some description. So we might here be looking at things like fraud detection or something like that. So looking at fraudulent behaviors or customers that are just cherry picking the site or whatever it may happen to be. And this NBA activity is probably also hitting models here, right? So trying to predict, if you like, fraudulent activity, bringing back a result from that hit, and then taking appropriate action in terms of running the appropriate event, right, in our web server. That in itself is also probably writing a bunch of logs as well. And all of those logs are going to be written into my information management system. So that might well be, we might start off with a data lake. But in most organizations, probably your organizations, you'll find there's a bunch of data warehouses, maybe some marts. Those are all being consumed by BI and OLAP systems as well, right? And all of that good stuff. Not to mention operational data stores and master data management systems and all sorts of other downstream things. From here, we're going to, of course, that's serving my operational requirements. So this is my operational environment here, if you like, right? Although obviously the information management system is quasi-operational. And below that line, though, we're then going to, so the question is, how are we how are we keeping the site fresh? How are we creating, optimizing other parts of the process? So how are we trying to drive customer interaction? So from here, we're going to develop a new model. So Didier has asked us to look at a particular problem. Maybe there's some work that we need to do around the number of baskets that are being abandoned by particular types of customer that Didier is concerned about, right? So we're going to do some machine learning model development here. Having created a model, which we're going to look at in a little bit, we're then going to need to deploy the model, right? So, so we're going to do deploy here. So we create the model, we deploy and manage the model. And in reality, what that means is that we're going to take the output, our model, and we're going to update or refresh or insert our model into our model serving here, right? The last thing we have to do, though, is we have to align our applications. So having made changes to our models, I mean, or having created new models, of course, they have to be called from somewhere. They have to be served from some particular kind of business process. And so we have to somehow align, do the CI/CD work with our applications to call the models at the appropriate time, right, in a sort of defensive or aggressive way. And what we see really pretty much as HPE, I think, is, it's all of this area here, it's all of these parts that are currently badly served, I'd suggest. Less so maybe these operational applications, although it's quite difficult for many organizations to reimagine all of their kind of very stateful, data-centric operational applications. But there's definitely, these are areas that we are very strongly working on, right? Again, let me stop there for a second. Does that make sense to people? We I like the idea of cheap learning. Oh, thanks, Ted. Yeah.
Did you want to poll for the pace and approach?
I'm sorry. Did you again?
Did you want to bring up a poll about the pace?
Let's just move on.
We don't have to.
Yeah. Let me move on just one more frame.
Okay, sure.
So what I've tried to describe, however badly, sorry for that, right, is that this whole idea of creating data science and operationalizing data science, if you like, and then iterating through and then improving data science and then finessing an application, if you like, to call that model, and all of the data and all of that data management thing are so closely intertwined. Now, your organization, maybe you're working on the data bit. Your organization, maybe you need to work more on the data science bit. Maybe you need to work more on the deployment side. Almost inevitably, most organizations now are struggling with the deployment side of all this, right? But probably it's going to be all four of those things that we've pictured. And what we see is successful organizations are able to, simply do the information management, do it simply because then it doesn't burn all the money you have and all of the effort and time you have, right? Do the model building simply and quickly because speed sometimes has a really important role to play. Deploy those models effortlessly and be able to maintain them simply as well, and at the same time align that to your business applications. But what I want you to do really is just double click a little bit on these areas, right, on the model building and then how you deploy and manage. Let's look at that quickly. Let me give you a simple example, because we haven't really looked at the definition of AI, machine learning and deep learning and neural nets and all that kind of stuff. Didn't know whether that was important. I'd be interested to hear, but I just thought you'd get bored too quickly, right? So I was just going to build a very simple decision tree, and just as an example of the kind of thing that we might see, just as one way of learning kind of what machine learning models is all about, really. Okay, so in my very simple example here, I've got, it looks like some kind of buy or not buy. So maybe I change this actually to, oh yeah, this is really churn, I have to say. So I think I probably need to change that back. This is really a churn problem, just looking at the data here. So this is kind of telco data looking at this, although not really. So I've got a table here. So I've got things like, I've got data from my contract information, payment information, behavior information. So how many calls people have made, CSR information, whether they've called into a call center to complain about coverage, that kind of thing. Socio-demographic information, so lifestyle information, perhaps, behavior information. And then labels, so whether someone has churned or not churned. And what we really want to do is try and train a model that's going to differentiate between those customers that have churned and those that haven't churned. And then we want to do is to apply that, if you like, to find customers that are risk from this moment forward. And this is, a simple decision tree, so some kind of classification and regression tree. And if we just consider two variables at this stage, age and income, right? Both numerical variables, so age and income. And all I've done is plotted on here all of the examples of people that have churned and not churned, so this person's churned and they're at this age and at this income level, okay? And then in effect, what the CART model does is it just traverses the model. So all it's going to do is it's going to traverse the income boundary here, or maybe the age boundary, and it's trying to identify a point at which it can discriminate between, an easy point to discriminate between those that have, I'm going to have to use blank, those that have churned and those that haven't. So maybe I'm going to use this as my first breakpoint. And then it'll continue on by going across the age axis in this case, right? And then, oh, look, there's another breakpoint here. So the mechanism it's using to look at entropy, this set, if you like, of those that have churned and those that haven't, can be tuned. And we just continue to move through creating these breakpoints, at whatever intervals, right? And we might continue until we reach a stopping point. And that stopping point might be the number of branches, or it might be the number of items in a set, or whatever it might happen to be, right? And typically what we would have done, by the way, so I probably should have said that to start with, is we probably would, there's different ways of doing this, but you may have split the data set into a training data set and a testing data set. Having built my model with my training data set, all I'm going to then do is I'm going to come through my testing data set and I'm going to plot, if you like, each one of these items. And so I've got the first one, it's at a particular age and income level, let's say, and it's in here, okay? And in this particular case, they didn't churn, okay? So this is my new item here, didn't churn. And I can look into here and I can say, well, actually, my prediction would have been right because they didn't churn. And look, it would have been in this group of people that churned, didn't churn, rather. And all I'm going to do, well, actually, what I should have said, sorry, is each one of these groups then, you can think about this as a decision tree. So our first break, I think, was here. Let's say it was at income level, let's say it's 50,000. Okay, so this is greater than 50K on this side and less than or equal to 50K on this side. And then my next branch was, let's say, at age 50, let's say, right? So age 50. And so on and so forth. So we're just going to build this decision tree. And when you get round to the leaf node, what we're going to do is you would choose, let's say, the dominant class in each one of these. So the dominant class in this group is no, clearly, right? 2, 4, 6, 8, 10, 12 no's and no yeses in this class. Here, they're all yeses, so the dominant class would be yes. Here, the dominant class is no, but there is one yes. So if an item fell into this class here, let's say, this is my new item, I would classify this as a no and a probability of 2, 4, 5, 4 over 5, right? So the probability of 4 over 5. Here, the dominant class would have been a yes, and the probability would be 2, 4, 6, 8, 9, 2, 4, so 7 over 9. Okay, got the idea? So in terms of how we would understand the model, how we would look at its performance, typically with a classification model, you just create a classification regression kind of approach here. You would create a confusion matrix. So this is no, yes, and this is true, actual, so ground truth, true, actual. And this is our predictions. And all we're going to do is, so having then run our test set through this decision tree and scoring each one of them, we were then just going to align whether our predictions were true or false or whatever. So this is our predicted value in here, let's say, right? And so we predicted yes, and the answer was no. We predicted yes, the answer was yes. We predicted yes, and so on and so forth. And we just fill the values in here. So maybe this is 50, this is 2000, this is 50, this is 250 or whatever. Okay, so what we're looking for, given the type of problem that we've got, is we're looking to understand whether this is a good model or a bad model. And so really what we're principally looking for is we are looking, for instance, this is an actual of yes, and we're clearly appalling in terms of our prediction rate here, right? Because we've predicted no on 2,000 occasions when the answer is yes, and so on and so forth, right? So just in terms of diagnostics, a decision table like this, some confusion matrix, makes a lot of sense. Okay, so Didier, now I think is the time to deploy our poll. So poll 2 then, if you wouldn't mind, just give us a flavour of where we are on this, right? Because I've been rabbiting on for some time. I much prefer PowerPoint presentations. Thank you for that. In fact, I probably would have voted that myself. So I'm guessing we're okay. And I really like, by the way, some people have contributed things I see in the chat, which is great, because this is a long way from done, and we can all learn. So it's fab, right? Okay, right. So we are desperately running out of time. So should we move on? Didi, I think you can probably close the poll. Probably the rest of them have drifted off already, right? So I'm going to assume those are, I can't remember why I'm here. Sorry, Ellen, did you want to get in?
I can't get out of what I'm doing here.
I'm guessing no.
No, I'm good. I'm good.
Okay, you're good. Okay, all right. So one of the things that's often talked about in data science is the fact that data scientists spend the majority of their time managing features, managing data, if you like, munging data. So, which is it's such an interesting area, really. And I just wanted to touch on it. I think, so, you'll hear the standard Pareto, 80-20 for, the amount of time a data scientist spends or wasted you'll often hear looking at data. And I'm not entirely convinced I would agree with it, to be honest. I think the first time around, when a data scientist is looking and investing in a particular set of data, let's say that's just for argument's sake customer data, inevitably building an understanding of that data is really critical. Looking at each attribute, understanding central tendency, understanding outliers and dealing with outliers is key. The performance of the models that are being built is really contingent on the kind of investment in the data. So I'm going to argue up front that giving the data scientists the tools to really help them understand the data and correlations between items of data is really super important. But there are some things, depending on the model you're building, that are, although a lot of techniques now, a lot of underlying algorithms, AutoML is there to help you create features automatically, a lot of data scientists still prefer to kind of invest in those features themselves. And I just wanted to spend 5 minutes looking at those kind of things, right? So, and I've got a list here. So things like outliers. So just to give you some simple examples, let's say we had that salary problem before, right? If you looked on a graph of salaries, so this is salary here, And we would probably find we would all be here, and then way over here, this will be Antonio, you know, and other CEOs, and this will be Didier here, right? This is Didier. Because we all know he does a great job and should be paid billions, right? So the problem, of course, is that if we just use this data untreated, in effect, it's going to be very hard for our algorithm to find a discernible pattern in this data. Now, it's certainly not impossible. And, you know, if you're doing deep learning or if you establish a neural net in the appropriate way, it's really super simple. But we can help our, you know, our machine learning model by doing something different. We might instead add a column to our data here that is, you know, let's say just a flag for an outlier flag for salary, right? So we might just exclude these from our, you know, maybe encoding it as a yes here. And for everybody else, we are going to expand this and we're going to break it maybe into a number of kind of segments. And so rather than having this continuous variable, we might instead break it into low, medium, and high. So we might actually create a categorical instead out of this. Right? So we might, so just as an example, right? So we might label it instead. We might, so some of the data here, for instance, we've got missing values. So what should we do with the missing value? You might decide on deleting this row completely and not using it at all. Or if you're short on data, you might decide, well, I don't want to do that. What I'm going to do instead is I'm going to impute a value here. So I'm going to use a regression model maybe to predict the income that this person would have had based on the other variables that I have, right? It's fairly commonplace. Or I might replace it with central tendency instead, because that might, you know, so that's not going to affect my model in the same way. One-hot encoding is another way of saying taking our low, medium, and high, rather than having low, medium, and high or something like that, we might instead, because we need to do maths on this, so we can look at this in more detail another time, but we might instead decide to have a column with low, a column with medium, and a column with high, and set the flag appropriately for these rows. So the same is true of any more, you know, categorical like this. So let's say whether they've the kind of product ownership or that kind of thing, you might expand those out to create this. In effect, what we're trying to do is create a longitudinal view of our customer, so or whatever, so that actually all of the data we need is spread in this one row for each one of our customers. So things like discretization, if you like, so making this discrete variable rather than having a continuous variable, normalizing data. The other thing that the problem we have here actually in our model is maybe this axis here was, let's say, between 0 and 99 years, right? Whereas our income range here might be between 1 and 1 million. And the problem is, in this particular case, is that inevitably this is going to make income too important. So actually putting them on the same the same ordinal axis in terms of values makes sense. So normalizing the data often with you know, normalizing it across a mean, you know, so it's all got a single, you know, one standard deviation, or potentially using something like Z-score or something like that. So there are a number of ways of doing it. I should have also mentioned, of course, this is, you know, this is only on 2 axes here. I've built my decision tree, looks very simple. In reality, of course, you're going to have hundreds of variables. So we've got an n-dimensional space that we are traversing, and the order at which it's making those decisions and traversing that data is really key. Now, Didier, I realize that we are getting to the end of our hour.
Absolutely.
And we've covered no ground, which is either a good sign or a really bad sign. I can't really tell which. Yeah, so we got to the end of our time. I suggest what we do is, because it's almost not, you know, it's kind of not worth a summary almost. We've talked about, what have we talked about? We've talked about briefly why data science. We've talked about the kind of data science we're trying to focus on, which is very much about these automated decisions, and we've talked about having an applications view. We've talked about how that might work in the real world, in a pseudo real world example, if you like, right? And those 4 components: information management, model building, deploying a model, and aligning the application. And we've just done one simple example using a decision tree of those things, right? And then we've looked at maybe some of the reasons why a data scientist would want to spend time finessing some of the data. And we've run out of time. So in advance, I'm going to thank you all for your patience. Hopefully you found it interesting. It is super important that you let us know whether you do think it's interesting. Well, let Didier know specifically, right? And whether you would like to do something like this again, perhaps better organized. Yeah, so that's it. Didier, maybe, or Ellen, sorry, can I hand back to you?
Sure. So while people are doing the poll, first of all, thanks, Doug. I think you opened up a lot of really rich examples. There was lots of conversation going on with the chat, which it sounds like you really got people thinking. Just for myself, a couple of pieces to pull out of that and think about going forward. And as you go to the next session, data really does make all the difference. And just having it isn't magic. That doesn't mean you can do anything with it. It's really understanding it, spending time exploring it, having people who are expert in handling it, and having people who are expert in the context around the data. In other words, who has domain knowledge that may be specialized. If you're a brain surgeon or you're doing rocket science or agriculture, it may be specialized simply in that you're an expert in how your own business works, and that is valuable domain knowledge. And that has to be coupled with the data science for all the things that Doug's talking about to actually come to.
Just to interrupt you briefly, I completely agree. This was where we were going on to, and what I'd like to do next time round, right? Which is talk about the process and what happens in each one of those steps in the process for real. And so talking about it in the context of things like Kubeflow and MLflow and some of the technologies that are out there. Again, it's not a product pitch. It's really just more of a, these are the capabilities that you need. Okay. So just as a taster, if you like, if we do run the second session.
Yeah, there was a fair amount of people asking for a second session, so I guess we are going to run that second session. I brought up another poll from which is more for us in the program, finding out if you like these kind of sessions. Let me know. We'll leave that poll for another few seconds. And with that, I would like to thank Hélène and Doug. We'll come back in a couple of months for that second part. And thanks everyone for joining that call. Unfortunately, I see people joining now, so I guess the time zone and the daylight saving times have probably killed us. But thanks for joining. That was a very interesting session and a great way to deliver it. Thank you, Doug.
Thank you, everybody.